Okay, guys, this is kind of an intro. Some of you may have seen this before. Some of you are seeing it for the first time, but this is the periodic table of elements. So this is every element that we are currently aware of, every element that's been discovered represented on a chart that was sort of developed by a Russian named Mendeleev, and all of the letters you see on it represent the name of things, elements found in nature, based on their Latin name. And so, for example, sometimes they won't match up really well, like gold and silver. There's silver right there, Ag. So whatever the word for silver is in Latin, it's Ag. Iron is ferrous in Latin. In English, it's iron, so that's a little different. Mercury, Hg. So anyway, many of them match up really well. Carbon, the letter C, and oxygen, the letter O. Many of them you know and you're aware of. So we're going to kind of look at just the way a periodic table is designed, and so that you can kind of understand. First of all, this first group right here, and I said the word group. Group represents all of the elements that reside in these vertical columns. So everything up and down here, that is a group. And that's something that these guys all have something in common. And it has to do with the configuration of the atom, the way that the atom is designed. Things that are in group 1, I've highlighted group 1 here, they all are an atom, and then on the outside shell there's one little negatively charged electron buzzing around, one loosely charged or loosely held electron buzzing around. So it's like a ball of electrons flowing around the nucleus, but one way out here. Everything in group 1 has that in common. Everything in group 2 has 2 electrons buzzing around out there. So the fewer electrons you have that an atom has in its outermost shell, the more volatile it's going to be, the more it's going to be likely to bond. So to show you how that works, we'll just zoom in on a hydrogen atom, which is at the top there. So a hydrogen atom has an atomic mass of 1.08. So typically it's just got one little proton here, and then buzzing around on its outermost shell it has one little electron. And that's what a hydrogen atom looks like. Okay? Now, group 1, group 2, group 3, group 4, group 5, group 6, all the way to group 18. Group 18, the name for elements in group 18 are the noble gases. And these guys have a full outer shell. So whatever their outermost shell is, it's full. So in the case of the top 2 here, just looking at those, helium has 2 protons on the inside and 2 electrons on the outside. So that's almost what a helium atom looks like. Now, because it's got an atomic mass of 4, there's also something we haven't really gone over yet, but 4 minus 2 means that it also has 2 neutrons on the inside. So those are your subatomic particles. You have electrons, and they're buzzing around outside of the nucleus. And you've got protons. They're the positively charged subatomic particles that are in the nucleus of an atom. And then you also have neutrons, and they're neutrally charged. They just add girth and oomph, mass to the atom. So they don't have a charge, so no charge. So if you lose a neutron, it really doesn't necessarily change the identity of an atom, but losing an electron or proton would change it substantially. So protons are positively charged and electrons are negatively charged. So each one of these squares just shows you what the atom would look like. Okay? Carbon. Let's look at carbon. Most of these atoms are metals. Some are nonmetals. We'll get into that. Carbon is a nonmetal. Nonmetals don't allow electricity to flow through them, and metals do. So carbon is what's called an insulator. It doesn't allow electricity to flow through it. So carbon is in group 14. Now, if we were to look at the horizontal row that carbon's in, 1, 2, it's in the horizontal row that it's in 2. So it's what's called period 2. Remember I told you this is called the periodic table of elements. So the rows that go back and forth this way, horizontally, those are called periods. Each row is called a period. So looking here, there's period 1, here's period 2, here's period 3, period 4, period 5, period 6, period 7. So that it just kind of shows you how that works. Well, carbon is group 14, period 2. So it's, if you've ever played the game Battleship, when we have school, a lot of times I'll pair people up and we'll play periodic table Battleship, and that's how you make your shots. Group 14, period 2. That'd be a hit if you have a boat on there. So let's look at what all these numbers on a carbon atom look like. They're kind of weird. So that number 6 is what's called its atomic number. That's its identity. That's what makes carbon carbon. So that stands for the number of protons in its nucleus. So if I drew the nucleus, I'm going to use a funny little picture. 1, 2, 3, 4, 5, and 6. It's called a Bohr model. It's not really what an atom looks like, but it helps you get an idea of what an atom looks like. Okay, so those 6 little dots right there represent the number of protons in a nucleus. Then I can use this number down here called the atomic mass. And I can determine the number of neutrons. The way I do that is I take the atomic mass, well, it's really close to 12, so I'm going to use the number 12, and I subtract the atomic number from it, and that gives me how many neutrons. Which 12 minus 6 is 6. 1, 2, 3, 4, 5, 6. So there's 6 neutrons in there also in the nucleus of an atom. Now the reason it's not an exact number, it's 12.01, that's because most atoms, most carbon atoms have 6 neutrons, and every now and then one has 7, just enough to throw the average off. So because there's no charge on a neutron, you can change the number of neutrons. It's still neutron. Okay. Now, it's still carbon. Now, the way that atoms are designed, they've got these electrons buzzing in a cloud all around them. Okay. And they buzz in different things called levels called valence shells. So, always the closest valence shell to the nucleus, it fills up with 2 electrons. Okay. Can't have any more than 2. It fills up with 2. So there's 2 electrons buzzing around this nucleus. Now, these are negatively charged, and you have to have your atom has to be balanced or neutral, which leaves 4 more out here. 1, 2, 3, 4. So there's 4 electrons buzzing around a carbon atom on the outside and 2 on the inside. Okay. Which means that the next shell out here isn't quite full. It doesn't fill up till 8. So that's why carbon attaches itself to so many other things. It's basically what you're made of. Carbon that's attached to hydrogen and oxygen and nitrogen. That's what I'm made of also. So carbon attaches itself to lots of stuff, and that's why, because it's only got 4 electrons in its outermost shell. And now carbon, which has 4 electrons in its outermost shell, also happens to be in group 14, which means that it has not very full. It has 4 to go, 4 electrons to fill up its outermost shell. So carbon's in group 14. Still have a little bit more time. Let's look at something that's in group 2. Well, let's just look at beryllium. Beryllium's in group 2. Because it's in group 2, I know it has 2 electrons in its outermost shell, but let's see why that's the case. Things that are in group 2 have 2 electrons in their outermost shell. They're very unstable. You can light them on fire very easily. As a matter of fact, things that are in group 2 are often what fireworks are made out of. But anyway, let's just look at what the atom would look like. This is its atomic number, 4, so let's make sure we write that we know it has 4 protons on its innermost nucleus. There's 4 protons. And then we have to do some math to figure out the number of neutrons. We take the atomic mass and we subtract the atomic number, and we end up getting the number of neutrons. 1, 2, 3, 4, 5. So that's what the nucleus of a beryllium atom might look like. Now, do you remember how many electrons are going to be in this innermost shell that buzz closest to it? Remember, the innermost shell fills up with how many electrons? Okay, which leaves us how many for the outermost shell? Okay, it's in group 2, so it has 2 electrons in its outermost shell. Okay, let me ask you a quick trivia question. Looking at this periodic table, can you tell me what is the address? Remember, give it to me by group and period. What is the address for the element nickel? Its atomic symbol is Ni. So can you tell me what group and period nickel is in? I'm going to tell you in just a minute. I'd like it if you would beat me to the punch. Okay, nickel is found right here. What group and what period is nickel in? Can you figure that out? 1, 2, 3, 4. So it's in period 4. And it's in group 10. Group 10. Okay. How about, give me another one here. How about tungsten? This is the metal that makes up the filament inside of the old light bulbs. That filament was made of tungsten. Okay, what was the address for tungsten? What group and what period? Can you figure it out? It's in 1, 2, 3, 4, 5, 6, period 6, group 6, tungsten. Took Thomas Edison several tries before he could figure out tungsten. I hope this helped you, and there's more coming.